again to my video channel, and today we are going to learn about the model evaluation. So let's start. Model evaluation. It is assessing machine learning performance. So model evaluation, it is a critical and crucial step to gauge how well a machine learning model performs on unseen data. It ensures that the model's predictions are reliable, accurate, and suitable for the given task. So evaluation methods it vary based on whether the task involves classification or regression. So here we have classification metrics. First we have accuracy. It is proportion of correct predictions among all the predictions that we have. Then we have precision. It measures how many of the predicted positives are actual positives out of the total positives and total negatives. Then we have recall, which assesses how many of the actual positives are correctly identified among all the positive values. Then we have F1 score, which is the harmonic mean of precision and recall, then particularly useful for imbalanced data sets. Then fifth we have is ROC AUC. It evaluates the trade-off between sensitivity and specificity, which summarizes the model's discriminatory power. So next we have regression matrix. So it consists of three things, which are three formulas basically. First is mean squared error, MSE, which is it highlights large errors by squaring the differences between predicted and actual values. Then we have mean absolute errors, which is MAE, which captures the average magnitude of prediction errors. Then we have R squared. It indicates the proportion of variance in dependent variable explained by the model. Then we have implementation tools. That is, in Python we use libraries like scikit learn for functions such as accuracy underscore score, mean squared error, and for ROC AUC score. And in R we utilize the caret package for a unified approach to compute evaluation metrics. Then through evaluation it ensures that the modeling generalize effectively, guiding decisions to improve or refine them further. Then how to perform model evaluations. We can use various metrics provided by the scikit-learn library for both classification and regression tasks to perform model evaluation. So here's a guide, like for example we have given the code which is for evaluating classification models. So from sklearn.metrics we can import accuracy score, precision score, recall score, F1 score, ROC score, and classification report. So for example, for classification we have accuracy, precision, recall. Individually we will define them. That is accuracy score, precision score, and recall score, F1 score, and ROC score. Then we will print all those scores and display them. Then here we will get our full classification report, which is for evaluating regression models. We have sklearn.metrics. We will importing about the errors like mean squared, mean absolute error, R2 score error. Okay. Then here is an example for regression model. So we have MAC and we will enter the value, then MAE we will enter the value, mean square error and mean absolute error. Then we will calculate the score, that is R2 score. That is proportion of variance explained by the model. Then we will print that mean squared error MSE and mean absolute error, which is MEE, and then we will print R squared, which is first we will enter that all the scores, mean squared, mean absolute, and R squared, and then we will enter its value and then perform calculation, and on based on that calculation we will get that result and then print, and then the result will be printed. So here we learned about two types of models. First is classification model and second is regression model. Okay. Then the key points to remember are classification metrics we will use for balancing data sets, but most probably focus will be on precision recall and F1 score. Then regression metrics for emphasizing large errors. Okay. Then visualization, it will visual tools like confusion metrics for classification of residual plots. Then we have accounting for unequal error costs. So in scenarios where different types of classification error carry unequal cost, we can account for this by adjusting the model to prioritize the model costly error. So we can do it by three ways. First is class weights. So we can assign weights to classes and models that support it, such as random forest, then class weight, and we can specify some custom weights to it. Then we can second as custom loss function. So for more control, we can create a custom loss function that penalizes certain errors more heavily. Okay. The third is confusion matrix analysis. So in this, we can identify and adjust for costly classification and ensure that evaluation metric aligns with business goals. So thank you so much for watching and listening. This was all for today.